Hello and welcome back. Chapter 3, our last section. Unit 3E. Numerical surprises, polygraphs, mammograms, and more. Who played better? Cheryl had a higher shooting percentage both in the first half at 40% and in the second half at 75% compared to Candace's 40. Does this mean that Cheryl had the better shooting percentage for the game? Let's just kind of look at this. Oh, it's killing me. I don't remember Cheryl's name. These are two really, really outstanding basketball players. Candace Parker played for Tennessee and then went into the pros also. Cheryl Swoops! I finally came up with it, Swoops. I think she played at Texas A&M, one of the early greats in women's basketball. Anyway, that was killing me. So in the first half, Cheryl went 4 for 10 for 40%, whereas Candace went 1 for 4 for 25%. In the second half, Cheryl was 3 for 4 for 75%, and Candace was 7 for 10 for 70%. So in the first half, Cheryl had a better shooting percentage than Candace. In the second half, Cheryl had a better shooting percentage than Candace. Does that mean Cheryl had a better had the better shooting percentage? Let's look. Turns out that Cheryl made only 7 baskets, 4 in the first half and 3 in the second half, on 14 total shots, 10 in the first half and 4 in the second half, for an overall shooting percentage of 7 out of 14, which is 50%. Candace, on the other hand, made a total of 8 baskets on 14 shots. Well, already we're 8 out of 14, which we know is more. Overall shooting percentage, now if we use the calculator, we could divide that at 57.1. Okay. All right, Candace had the better shooting percentage. Even though Cheryl had a higher shooting percentage in both halves, Candace had a better overall shooting percentage for the game. Yeah, right, it happens. Now, when you get test results, there are true positives, and this is when a test correctly reports a positive result. There's a false positive, where a test incorrectly reports a positive test. Right? It's not actually positive, but it says it's positive. There's a true negative, and similarly, a false negative. All right? Okay, so true positive, false positive. The test says it's positive, and then that's either true or false. The test says it's negative, and then that's either true or false. Right? It's kind of like flipping 2 coins, isn't it? Based on the numbers in the table below, what is the percentage of women with negative test results who actually have cancer? False negatives. They say you don't, but you actually do. Well, here's a summary for 10,000 mammograms in which 100 of the women have malignant tumors and 9,900 have benign tumors. Okay, so we have negatives, false negatives, and we have true negatives. All right, let's take a look. For the 10,000 cases summarized in Table 3.7, the mammograms are negative for 15 women with cancer and 8,415 women with benign tumors. The total number of negative test results is 15 plus 8,415, which is 8,430. The percentage of women with false negatives, right? They were negative, but it was wrong. So the ones that were wrong out of all the negatives, 15 divided by 8,430 turns out to be 0.0018. Move this 2 decimal places, and we have our percentage, 0.18%. That's less than 2 in 1,000. So the chance that a woman with a negative mammogram has cancer is actually very small. And I'm gonna throw this out here. Mammograms, always a good idea. Once you hit 40, women and men. Sometimes men need mammogram too. I'm just saying, we all have mammos to look at. That's not the word. Suppose that 1,000 people take the polygraph test, 10 of whom lie, and the polygraph is 90% accurate. How many of those applicants who were accused of lying were actually telling the truth? Let's look at this in a tree graph. So we have 1,000 applicants. We know 10 of them lie. That means 990 tell the truth. Okay. A polygraph does not catch 10% of the 10. So the polygraph did not catch this one liar. But the polygraph is 90% accurate. So it'll take 90% of those 10. It'll catch those 9 liars. All right, Polygraph has it. Now, 990 people are telling the truth. The Polygraph says 10% of those are liars, and that's 99 people that were telling the truth that it said, nah, you're lying. But the Polygraph finds that 891 of the people out of the 990 are truthful. But what are we actually looking at? 9 plus 99, which is 108, are accused of lying. 99 of those are falsely accused. And if you look at 99 over 108, that's going to be quite the percentage. It's going to be really close to, this is why polygraphs are not allowed in court. They are not reliable enough. Not nearly enough. All right, that 90% accuracy blows according to court. Let's look at high school drug testing. All athletes participating in a regional high school track and field championship must provide a urine sample for a drug test. Those who test positive for drugs are eliminated from the meet and suspended from competition for the following year. Studies show that, at the laboratory selected, the drug tests are 95% accurate. Assume that 4% of the athletes actually use drugs. What fraction of the athletes who failed the test are falsely accused and therefore suspended without cause? Ooh. The easiest way to answer this question is by using some sample numbers. So we're going to take a nice big easy round number like 1,000 athletes in the meet. 4% or 40 athletes actually use drugs. The remaining 960 athletes do not use drugs. In that case, the 95% accurate drug test should return the following results. 95% of the 40 athletes who use drugs, or 95 of 40 is 38 athletes, will test positive. All right, of the ones that use drugs, 38 of them will test positive. The other 2 athletes who use drugs test negative. So 2 got away with it. All right, not bad. 95% of the 960 athletes who do not use drugs tested negative. But 5%, right, the other 5%, tested positive. The number of athletes who fail despite not using drugs, 5% of that 960 is 48. The total number of athletes who test positive is 38 plus 48. But 48 of these athletes, or 48 out of 86, which is 56%, are actually non-users. Despite the 95% accuracy of the drug test, more than half of the suspended students are innocent of drug use. Something important to note here, this is why a lot of times in the Olympics they'll have a second test. If you fail the first test, they'll have you do a second test just to see if it was a false positive or not. All right, politics, because nothing is so much more agreeable than politics. Suppose that federal government spending for a popular education program was $100 million this year, and that Congress has proposed to increase this amount to $102 million for the next year. All right, seems legit. Explain how this proposal can cause lobbyists who oppose the program to complain about the size of the increase, while lobbyists who support the program complain that it's being cut. Assume that the consumer price index is expected to rise by 3% over the next year. All right, so the rich pay more under tax cuts. Here's 2 tables. High-income households receive highest dollar benefit from tax cuts. Right, so benefits, whatnot, average tax benefit, taxpayer income level, all the politics. How do you want to spend this? Now, we can see here that spending is rising, right? How do we see spending is rising there? We don't. Spending is rising. Oh yeah, that's just from the original. I knew that. It's going from 100 million to 102 million. So the opponents can just say, hey, look, 102 is more than 100. You shouldn't pay more. However, if the consumer price index rises by 3%, then this year's 100 million is equivalent to 103 million next year, which means that an increase to 102 million is not enough of an increase to keep pace with inflation. For this reason, The supporters can legitimately claim that the funding is being cut in constant dollars because 102 million next year will not buy as much as 100 million this year. All right. There we go. Still comparing numbers. How does it these are the numbers of our lives, right? The CPI, prices one year to the next, politics. Someone's trying to get away from it all with sports. Thank you very, very much for listening.